Before we start doing tables, I just wanted to do a quick video on translating graphs. Translating in graphs means moving the graph from place to place without changing its shape. So let's take the general setup. So I'm using Algebra, which is free to use. It's pretty good software, especially for free software. And I'm going to create a graph here, y equals 1x plus 1, the green line there. So to move it to left and right, it doesn't really make much sense because it's always going to be the same shape. So it's going to go up here for forever and ever and ever, and down there forever and ever and ever. But we can move it up and down. And we would just do that by changing the c at the end of it. So it's going to be 1x plus 1 at the moment. And if I change that c at the end here, if you look at this number here, it's just going to be moving up, and then it's going to be moving down again as c gets smaller and smaller as this loop goes on and on and on. And I'm going to stop it there at 4.65. And notice that this is still the y-intercept. So this can go down to infinity, this can go up to infinity. It's always going to have that same shape, it's always going to have that same gradient unless I change it. And it's going to move it back to 1. Yep. So it's just going to go up and down. So whether this is translating it up and down or to the left and the right, kind of the same thing when we're talking about lines. Okay, enough of that. Now let's talk about exponential graphs. So these are graphs that look like that. So this one is y equals 2 to the power of x. And how would we move this to the left and the right? So I'm going to get that same graph. So this is the graph y equals 2x. But notice it's 2x plus d, and d is 0 and it doesn't show it there. So if I want to move this up or down, I'm just going to change that at the end of it. So if I stop that there, so this is 2x plus 5. And notice it goes up. It doesn't cross it at 5 in this case. It crosses it at 6, and we're going to get to that in a second. And then if we change that number at the end, it's going to go up and down, and it can go up and down as far as we want. And if I don't push pause, it's going to go up and down all day pretty nicely. Okay, so I'm gonna set that at 0 again. Now, how do I move it from go to 0? There we go. How do I move it from left to right? The answer is kind of a strange one. And if you look at this graph here, y equals 2x plus b. So I'm going to change that b. And watch what happens. No, tell a lie. I was changing the d. Oh, blooper. Okay. If we change that number that's in the bracket, that's in the exponent form, the exponent position, the shape is not going to change, but it's going to kind of move to the left and to the right. But notice what's happening here as we add. So it's 2x plus 1.01. It's moved to the left. So if we add, it moves to the left. If we subtract, it moves to the right. So this is getting So this is getting more and more negative. And now it's getting more and more positive as it's moving to the left. So what's this number up here? And point to it there. Okay, what happens when we change the number, the base number? Well, it does something quite interesting. So this is y equals 2 to the power of x. And it goes down here and it gets closer and closer and closer to the x-axis. If I zoomed in, it's not going to quite ever touch that x-axis. It's an asymptote, which means it's going to get really, really, really close to that x-axis as we go on for infinity, but it never quite gets there. And notice where it crosses the y-axis. The y-axis, it crosses it at 1. So think about why that is. And now I'm going to put in y equals 3 to the x. Okay, so when x is greater than 0, it kind of shoots up faster than this one. But notice what happens when it's below that 0 point, that x equals 0. It actually goes below and it's going to approach that x-axis quicker. It's never going to get there. It's still an asymptote. And if we do it for 4 and for 5, the pattern continues. Notice though, if we zoom in, they all cross the y-axis at 1. Why is that? Well, 2 to the power of 0 is 1. 3 to the power of 0 is 1. 4 to the power of 0 is 1. So they kind of converge on that point there. So just to show you that they never actually, it never actually touches the y-axis, the x-axis I should say. I'm going to zoom in and it's getting closer and closer and closer to that x-axis as I zoom in, but it never quite gets there. It kind of looks like it's crossing it because I've changed the settings for that line so you can see it. But it never quite gets there. And if we zoom in, it's going to get closer and closer and closer, and these other ones are going to be even closer. It looks like it's crossing the x-axis, but it's just because the lines are quite thick. And I just wanted to cover that because it's quite an important concept to grasp.